Hi, in this video I'm going to demonstrate how my analog synthesizer project works. First, I want to mention what the fundamental idea of this project is. The whole idea of this project is that I want to connect my synthesizer, my Korg MS-20, with other synthesizers, and to also connect my synthesizer with itself multiple times to route different chords and different control voltages to different places. In order to do this, I need some extra circuitry to duplicate outputs and send them to different places. So the series of modules that I've created are a very basic attempt at trying to do this. And certainly this is not the end point of this project. I expect this to go on much longer than this over the upcoming January term, but this is the fundamental building blocks that I tend to then grow upon. The first thing I want to talk about is the voltage-controlled oscillator, which is located right here. Basically, it's two transistors adjusted in an AND gate configuration so that they essentially multiply one another, so that the voltage will be between 0 and the output of 9. So the first thing I'd like to demonstrate to you is my sawtooth wave. So this is the sound of the sawtooth wave coming out of my analog oscillator, and you can see that it's very steady. It is dependent, however, on the batteries, which is annoying. Now I am going to adjust the frequency of this wave, and you will be able to hear it as I do so. I will use a screwdriver right here, to adjust the transistor, which is located right there. And you will be able to hear the input changing the bases, and it will adjust the LFO. So here we go. And now coming back down. Alright, for this incoming voltage level, this is about the limit, but it can go lower than this if you adjust the settings properly. Notice that the voltage-controlled oscillator's output is very stable and shaped like a reverse sawtooth at the moment. However, when I connect it into anything, thereby applying a load, you will see that the wave becomes very distorted. And this is simply because of some interaction between the source and what's driving it. If you see me disconnect, it immediately goes away. And that's me just connecting it into my mixer. If I now connect it into some other spot on my synth, a very similar thing happens. And this will change the resulting sound, so it is important to consider what you plug your machine into. And this is something for me to consider for later versions of this project. Next, I want to talk about the buffer circuit. It connects the inverting input with the output so that we get unity gain. And that is pretty much all there is to it. It's one of the simplest circuits you can build. You can connect the same input to a bunch of different op-amps, and that way you have outputs which are separate from one another, and they do not have the ability to load down one another. and so I'm going to demonstrate this now. Here we have the oscilloscope displaying the input and the output of my buffer, which is connected just off screen, and I'm going to play in a note from the synthesizer, and you will see that it shows up both on the input, which I'm measuring across the yellow line at the top, and across the output, which is measured via the blue trace at the bottom. So I'm going to bring in my, you can hear the synth coming in. And you can see that both the input and the output are mirrored pretty much exactly. There are a few blips here and there, but they're pretty much exactly the same. I'm going to play a simple note on the synth, and you're going to hear it. So that is the input. And now, off screen, you're going to see me plug in the output from this into the incoming adjusting LFO wave, and you should hear it. Now I'm going to take a screwdriver and increase the frequency. So that is the resultant tremolo we get, and I'm quite happy with it. That was just me adjusting the filter. And then it fades away. So that is the resultant VCA signal we get, and it works even better than I expected. Okay, I'm going to now talk about the envelope follower. You can see right here I have my envelope follower with a capacitor in it that's currently 10 microfarads. And there's an LED blinking on, which is connected to the comparator circuit to show that it's working. So off screen, I have the envelope follower hooked up, and it's just a talk show coming out of an AM radio station. And what I'm doing is I'm porting it through the envelope follower, and you should see this LED light up as it detects certain peaks, and hopefully if I did it right, it may even have some variation in its lighting. Also, you will see the trace on the oscilloscope go up when the voltage passes certain levels. So I'm going to bring up the envelope follower now.
I don't know if we want to talk about Canner before we get into Ntilikina. No. Okay. All right. Ntilikina, to me, just continues to grow. He seems to play better against the better players. It's almost like he studies them more than he studies maybe some other players that he's not ready for, and then he gets torn up. But this is another one of those games where you watch him, and I really do think that Baker complements him really well.
Does.
Because Baker's a small guy for a 2.
So obviously they're talking about some, I don't even know what.
They get after it. They don't give you anything.
And you can see the hard clipping at the top because of the fact that this is radio, so it's very hard compressed, and that's clearly visible. But it's definitely working. It's definitely following the signal. So that's it. Those are all the parts of the circuit. In an effort to make sure that I do not harm my synthesizer in any way, I am using a series of Zener diodes to limit or regulate the amount of voltage that can appear at the output. So what I'm doing right now is I have 2 Zener diodes which are back to back, but they're facing in opposite directions. They're in series. They are also in series with a 470 ohm resistor. And so What's going to happen is that for each half of the wave, because it goes between plus and minus 5 volts or greater, you will see no distortion before it reaches that threshold. It's really about 4.7. And then after that, you will begin to see clipping, very hard clipping. So what I'm doing right now is I'm outputting some sort of low frequency oscillation, and I'm controlling its level via my mixer right here. And as I increase it, you will see the wave appear here, because it's measured across the two Zener diodes. So I'm raising it now. You will see the trigger take hold, and the wave becomes stable. And right now it looks totally fine. I can adjust the speed of the wave and change its shape, and it does not have any clipping in it. All those changes were made on the synth itself. However, once I raise the level to a certain point, you'll see that we have flat tops and flat bottoms, and that's because the machine is beginning to take hold. So you can see right now I'm super hard clipping the two Zener diodes, and it's almost a square wave now. This allows me to regulate the amount of voltage going to different parts of my circuit, which is important to prevent my synth from blowing up. Even though I've been told that's not a very large concern, I still want to be as cautious as I can be. I think it will be worth it in the end. And so that is my current setup with Zener diodes.